In this lesson, you'll learn how to find the slopes of lines and use slope to identify parallel and perpendicular lines. How is slope used in transportation? Traffic signs are often used to alert drivers to road conditions. The sign at the right indicates a hill with a 6% grade. This means that the road will rise or fall 6 feet vertically for every 100 feet of horizontal travel. The slope of a line is the ratio of its vertical rise to its horizontal run. So rise over run, rise over run. In a coordinate plane, the slope of the line is the ratio of the change in the y-axis along the change in the x-axis. The slope m of a line containing 2 points with coordinates x sub 1, y sub 1, and x sub 2, y sub 2 is given by the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1, where x sub 1 cannot equal x sub 2 because division by 0 is undefined. Find the slope of the line, and they were kind enough to graph it for us. So this line is going down from positive 7 to negative 1, so down 8 and over 2. Just using the basic definition of slope as rise or run, it's negative 8 over 2, which reduces to negative 4. Okay, I'm going down 7 over 0. So negative 7 over 0, division by 0 is undefined, so the slope of a vertical line is undefined. This line is going from negative 5 up to positive 2, so that's a rise of 7, and the run from negative 2 to positive 6 is 8. Okay, that's just what we have. Rise over run is 7 over 8. And this time I've got a rise of 0 and a run of 8. So 0 divided by 8. I can take 0 and divide it into 8 pieces if I want. I have 0 in each piece. So a horizontal line has a slope of 0. The slope of a line can be used to identify the coordinates of any point on the line. It can also be used to describe a rate of change. The rate of change describes how a quantity is changing over time. For one manufacturer of camping equipment, between 1990 and 2000, the annual sales increased by 7.4 million per year. In 2000, the total sales were 85.9 million. If sales increase at the same rate, what will the total sales be in 2010? The problem gave us a slope, so it increased by 7.4 million per year. That's my slope. And it gave us 1 point. So in 2000, time is always our independent variable. It changes of its own accord. The total sales were 85.9 million. And they want us to find the sales in 2010. So we're looking for that second y value. We can just plug and chug into our formula. We know m is 7.4, y sub 2 is what we're looking for, y sub 1 is 85.9, x sub 2 was 2010, and x sub 1 was 2000. 2010 minus 2000 is 10. So to solve the equation, we want to undo division with multiplying. So multiply both sides of the equation by 10. So we have 74 equals y sub 2 minus 85.9. I'm going to add 85.9 to both sides of the equation. And we get a prediction of 159.9 million dollars. Now, of course, we know that linear extrapolations predicting into the future are notoriously unreliable, but still, in theory, that's where it should be. Examine the graphs of lines L, M, and N. Lines L and M are parallel, and line N is perpendicular to L and M. The slope of M, it's going down 3 over 5, as is the slope of M, down 3 over 5. The slope of N is going up 5 over 3. Because lines L and M are parallel, their slopes are the same. Line N is perpendicular to lines L and M, and its slope is the opposite reciprocal of the slopes of lines L and M. That is, -3/5 times 5/3 is -1. This suggests two important algebraic properties of parallel and perpendicular lines. Two non-vertical lines have the same slope if and only if they are parallel, and two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Determine whether line FG and line HJ are parallel, perpendicular, or neither. So we're going to use our slope formula and find their slopes. So for line FG, change in y over change in x is going to be minus negative, that's a plus. So -1 plus 3 is 2 over -3. And for HJ, change in y, 3 minus 0 is 3 over change in x, 6 minus 5 is 1. So that's going to be neither. So once again, we need to find the slope of both lines. -3 minus 2 is -5. 6 minus 4 is 2. 10 minus 5 is 5. And -3 minus -1 be the same as +1 is -2. So they are both -5/2. So the slopes are the same. The lines are parallel. Graph a line that contains the point 5, 1 and is parallel to line MN with points -2, 4 and 2, 1. We could use the slope formula and calculate the slope of line MN algebraically. So change in y is going to be -3 over change in x is 4. Or we could do it the old-fashioned way, which is counting. I count down 3 over 4. So my slope is -3/4 that way as well. So now all we have to do is plot our point, which is 5 to the right, 1 up. And okay, yes, they made the square too small. So if I want to go down 3, I can't go over 4. So on their little piece of graph paper, I could go up 3 and 4 to the left and get to the point 1, 4. The slope of a line is the ratio of its vertical rise to its horizontal run. Parallel lines have the same slope, while perpendicular lines have slopes whose product is -1.